In this subsection, you will understand how to use matrix method to solve simultaneous equations. Here we have a simultaneous equation, and you're asked to use a matrix method to solve for x and y. The first thing you need to do is to write your equation in the form shown here, where A is the 2 by 2 matrix, which is derived from the coefficients of x and y. And then here the vector x here, this represents a vector, represents x, y, and then B here represents 15, 1. So here we write the matrix in the form as the first thing you need to do. The next thing you need to do is to find the determinant of the matrix, of the 2 by 2 matrix A. A here represents the matrix 7, 3, 3, 4. So to find the determinant, we multiply the leading diagonal, 7 times 4, subtract the product of the elements in the non-leading diagonal, which is 3 times 3, and we get 19. After we find the determinant, then we find the inverse of the matrix. So the next step is to find the inverse of the matrix, which the inverse is 1 over the determinant. And then what we do, we interchange the elements in the original matrix here. So where I have 7 here, I interchange it with 4, and where I have 4, interchange it with 7. And then what we do, the elements in the non-leading diagonal, we multiply them by minus 1. So that's how we get minus 3, 3 there. After that, what you need to do now is to pay close attention, because you're going to use this inverse to multiply the original matrix which was given up here, which is AX equals B. We multiply the left hand side by the inverse of the matrix, and we multiply the right hand side. And as you know, the inverse times a matrix gives us the identity matrix. So the left hand side here is already solved. So all you have to do is to work out the right hand side. So here we multiply both sides by the inverse of the matrix. So the left hand side, the inverse here, is multiplied by the matrix A. And then the right hand side, A inverse, the inverse is multiplied by 15, 1. Okay? And then upon simplifying the left hand side, because a matrix times the inverse gives you the identity matrix, which is 1, 0, 0, 1. And the right hand side, we need to simplify that. So here we simplify the right hand side, which we multiply the row times the column. So the first row here is 4 minus 3 times the column 15, 1. So 15 times 4 gives us 60, and then minus 3 times 1 gives us minus 3. So it's 50 minus 3, 60 minus 3 there, and that gives us 57. And then we multiply the second row by the column here. So 15 times 3, that's minus 45, plus 7 times 1, and that gives us 7. So minus 45 plus 7 gives us minus 38, and 1/9 of this is just a fraction. 1/9 of 57 would give us 3. It's also very important for you to note that the left hand side here, 1, 0, 0, 1, is the identity matrix, and it behaves just like the number 1. So all you have to do is to do 1 times xy there, and that's going to give you xy. So the left hand side we get xy, and when we simplify the right hand side here, we get 3 minus 2. So we have now solved the simultaneous equation. So x is 3 and y is minus 2. And that's the final step there. Now, simultaneous equations are solved using the matrix method following these 3 basic steps here. First step is to write the equation in the form AX equals B, where A here is the 2 by 2 matrix, and the X here represents the column vector XY, and B represents 15, 1 here. And then the second step is to multiply the matrix by the inverse by the matrix, the original matrix. And as you know, A inverse times A gives us the identity matrix, and the identity matrix behaves like 1, so 1 times x here just gives us x. Then the right hand side, you multiply the inverse times B, which is 15(1) here, and you get the answer. So thank you for listening, and I hope you do understand how to solve simultaneous equations using the matrix method.